Good afternoon. These are your notes for 10.2, Residuals. And I have a lot of this written down already, so if you need to take some time to pause and copy down the notes, now would be a great time to do so. Okay, residuals. Residual is the distance between a data point and a line of fit. Yesterday we practiced drawing the lines of fit. So it's to get it, it's the actual y value minus the predicted y value. So the actual y value is what it is. The predicted would be the value that falls on the line. When we do a residual plot, obviously that's a plot of the residual points. If they're random, the line is a good fit. And if they're non-random, the line is a bad fit. And when they're non-random, they're going to make usually a curvy pattern. But you will clearly see that it's a pattern. Okay, we're going to turn to page 363 in the book. It's got a problem for us that we're going to practice making a residual. We're going to start with a table. If I can find the page, excuse me. Okay, so, and then in your book there's actually, here's 3 examples of residual plots. The distribution of residuals is random about the x-axis, and it's tight, so that's a very good fit. In the second one, it's random, but it's a loose fit, so the data fits the model, but it's a weak fit. And then the distribution of these residuals is not random. You can see it forms, I said, like a little curvy thing. That means that the line doesn't fit the data well. Okay? So the problem that we're going to use is down below. And it says the table lists the median age of females living in the United States based on the results of the United States Census over the past few decades. Follow the steps listed to complete the task. So A says use the table to create a table of paired values for x and y. Let x represent the time in years after 1970 and y represent the median age of females. So, and I kind of have the whole thing written out here, but this is the first step, the XY paired table. So the first value on that table was the year was 1970, so that's going to be 0, since it says it's years since 1970. And the median age there was 29.2. The next year they give us was 1980, so that'll be 10, because that's 10 years since 1970. That's 31.3. The next is 1990, so that would be 20. And that's 34.0. The next one is 2000, so 30. And that was 36.5. And the last is 2010, so for us that would be 40. And the median age was 38.2. Okay, on page 364, part B says use the residuals to calculate the quality of the fit for the line y equals 0.25x plus 29, where y is the median age and x is the year since 1970. So what we're going to do, this would be the predicted line. Or the predicted value of y. So we're going to take our values from x, plug them in. So if I plug 0 in, I would get 29.0. If I plug 10 in, I get 31.5. If I put 20 in there, I get 34.0. 30 gives me 36.5. And plugging 40 in gives me 39.0. To get the residuals, again, in the definitions, I told you it's up here, the actual y value minus the predicted y value. So we're going to go here, and you might want to write it in so you don't forget what you're doing. But it's 29.2 minus 29 gives you 0.2. 31.3 minus 31.5, excuse me, gives us negative 0.2. 34 minus 34 is 0. 36.5 minus 36.5 is 0. And 38.2 minus 39 is negative 0.8. The next thing you're going to do is plot them on a grid. So we have 0.8, 0.4, 0, negative 0.4, negative 0.8. Because that's going to be pretty easy to graph on. And then along the bottom, I went ahead and put the tick marks instead of right here for the x values. I suppose I could 10, 20, 30, 40, 50. Put the marks up there too. So my first one is 0 and 0.2. My next is 10 and negative 0.2. Then I have 20 and 0, 30 and 0, 40, negative 0.8. Okay, so by looking at that, we can see it's not a pattern, it's random, but it's fairly weak. So we would say this is random with a weak fit. Because this one's all the way down here. The last thing I have is the squared residuals. And by analyzing the squared residuals, we can tell what the line of fit would be, or if it's a good line of fit or not. So if we squared the residuals, 0.2 squared is 0.04. Negative 0.2 squared is 0.04. 0 squared is 0. 0 squared is 0. And negative 0.8 squared is 0.64. Okay, we can add these up. This adds up to 0.72. Excuse me. And this will tell us because the closer the sum of the squared residuals is to 0, the better the fit. So that's very close to 1, so it's not super close, which makes it a weak line of fit. Your homework for 10.2 is on page 370. It's numbers 8 through 14 even. And I'm going to go ahead and do number 8 with you because we did not do anything like this yet. Well, let me take that back. We did it, we just didn't do a double. So, excuse me. What they're wanting to know in 8 through 14 is here's a set of data, Now, here are two lines. Which one is the better fit? So we're going to put it two. Basically, we're going to make what we did up top for the example, but we're going to do two in the same chart. So the x values they give us for 8 are 1, 2, 3, and 4. And the y values are 5, 3, 6, 4. So the first thing I'm going to do, this is my first predicted y. If I substitute 1 in, I get 3. 2 gives me 4. 3 would give me 5. And 4 is 6. The residual, so the actual minus the predicted, would give me 2, -1, 1, and -2. And then I need to square all of those, so I get 4, 1, 1, and 4. Then you're going to add your squared residuals, and those add to 10. The other line they gave us to try was y equals x plus 2.2. So if I put a 1 in there, I get 3.2. 2 would give me 4.2. 5 would give me 3 would give me 5.2. And 4 would give me 6.2. The residuals, 4 minus 3.2 is 1.8. 1 minus 4.2 is negative, or not 1, sorry, 2 minus 4.2 is negative 1.2. Okay, and that's a good, so you have to be real careful when you're subtracting. Three minus 5.2 is I'm sorry, 6. I'm reading the x's, excuse me. 6 minus 5.2 is 0.8, and 4 minus 6.2 is negative 2.2. Got to be careful of the columns that you're reading. You can see, even I'm guilty of that. Okay, so then we're going to square those. 1.8 squared is 3.24. Negative 1.2 squared is 1.44. 0.8 is 0.64. And negative 2.2 is 4.84. When I add those up, I get 10.16. So they're very, very close, but the one that's closer to 0 is the better line of fit. So for this data set, we would want to use y equals x plus 2. Okay, so you need to continue to do that for 10, 12, and 14. All right, I hope you have a nice afternoon.